Okay, this video will be kind of like an answer key or how to do certain type of problems. I'm going to try to post one about every day or so, and this one I got from a person on my AP Facebook, Sean Milliken. He kind of has been writing out some of these review questions, and I think they would be really good for you to do. So let me start with this one right here. Anyway, so this is a problem where you're mixing two things and you're getting a precipitate, and you got to figure out the limiting reagent. All right, so what I look at is trying to figure out this is you can see that this one, there's 500 milliliters of 0.2 molar and 500 milliliters of 0.15 molar. And so you need twice as many moles of silver nitrate, and you don't quite have twice as much molarity, so I'm going to guess that the silver nitrate is the limiting reagent. So what I usually do is like pick one and I guess which one is I think is limiting. And then what I'm going to do is I'm just going to do a problem to make sure that I'm right. Okay, so what I'm going to do is I'm going to start off with this 500 milliliters of this silver nitrate. And remember that whenever you take a volume and you multiply it times its molarity, but you got to break it into the correct units. So that's the moles of silver nitrate for 1,000 milliliters. Okay, so I broke the molarity into moles per milliliters. If you do that, you end up getting the milliliters cancel and you end up getting moles. But I want to keep on going here because I'm trying to kind of do this problem down here, but I'm also trying to prove that I guessed that the silver nitrate was the limiting reagent. Now, after you change to moles comes the mole ratio. For every 2 moles of silver nitrate that react, you're going to need 1 mole of sodium carbonate according to the equation up here. And then I can, if you look, you would be in moles right now of sodium carbonate. So then what you can do is you can use the molarity of that. And so the molarity of that is 0.15 moles of sodium carbonate for every 1,000 milliliters. Okay, now notice I put, oh, did that backwards. See the principle of diagonality. Always watch that. You can see I did that backwards. Let's go back to this here. Okay, and so this should be 0.15 moles sodium carbonate for every 1,000 milliliters. That's the molarity of sodium carbonate. Now, if you solve this problem, it's going to say that you need 333.3 milliliters of sodium carbonate. That's how much you need. Now, how much do you have? Well, you have 500. So you're only going to use 333 if all of the silver nitrate reacts. So the limiting reagent or reactant is silver nitrate. Now, the amount of excess reagent, okay, how much do you have left over? Well, you're starting off with 500 milliliters, and you're going to need 333.3 milliliters. So if you just subtract, you end up having 166.7 milliliters left over. Okay, now the next thing is calculate the grams of silver carbonate. So we're trying to get the grams of the precipitate. So, since you know the limiting reagent, you might as well start with that. You have 500 milliliters of silver nitrate, and the molarity is 0.2 moles of silver nitrate for every 1,000 milliliters. And the mole ratio comes next. For every 2 moles of silver nitrate that react, you're going to get 1 mole of silver carbonate. And then you got to change the silver carbonate to grams. 1 mole silver carbonate. And the grams of silver carbonate, if you do the molar mass, 275.75 grams of silver carbonate. And if you solve that, it ends up being about 13.8 grams. And I guess since this only went to 2 significant digits, the molarity right here, I'm going to just round that to 14 grams. Okay, all right, let's go on to the next question. Okay, write the net ionic equation for this reaction. Okay, so remember with a net ionic equation, you can cross off any spectator ions. And so sodium is AQ here, it's AQ here. Nitrate is AQ here, nitrate is AQ there. Remember, nitrate is one of those ones that they always want you to remember, that's AQ. So basically, we got 2 silver ions because it's AQ. Remember, on the net ionic equation, if it's AQ here and it's an ion, you got to show it. Plus a carbonate ion, CO3, 2 negative, AQ, gives Ag2CO3 solid. Remember, your net ionic equation should balance in terms of atoms, 2 silvers, 1 carbonate, and it should also balance in terms of charge. 2 positive ones and 2 negatives make this side a net of 0, and this is just a solid, so it's 0. Okay, next. Okay, so this one, the student is basically wanting to know, like at equilibrium, what's the concentration of silver in the solution. So what you're going to do first in doing this is whenever you see one of these equilibriums, sometimes you don't need them, but it's always best to think about an ice table, and on this one you're going to need it. Okay, so 2Ag plus 1 plus CO3 2 minus. Okay, so we'll make our ice table. Now remember, solids aren't going to be part of the equilibrium expression, so we don't need to worry about that. Now, basically, here's kind of the thing. I kind of gave you a hint that this is a common ion type of problem because, so if you remember from the first part, we're mixing these two together, but the problem is after we mix them together, there's some left over, and the excess reagent is this Na2CO3. Na2CO3 is left over, and there's 166.7 milliliters of that. So we know that we have 166.7 milliliters of sodium carbonate. Now, the thing is, we can't, like in the past, like a lot of times we just put 0 and 0 there, but that's if it's in pure water. But this stuff is going to shift back and forth when it reaches equilibrium, but it's going to be in a solution where there's some excess carbonate. So there's already some carbonate in there, so we got to figure that number out. What's the molarity of our sodium carbonate? Okay, so basically we're going to take the volume of it, and we're going to take the molarity of it, and that's going to be 0.15 moles of sodium carbonate, Na2CO3, and that's in 1,000 milliliters. Now, we want just the molarity of the carbonate, that's the common ion, and so for every 1 mole of Na2CO3, you have 1 mole carbonate. And if you do that math, you get 0.025 moles of just carbonate. Now, but we got to find the molarity of it. So we're going to take that 0.025 moles of our carbonate, and we're going to divide that by the volume. But they're mixing 500 milliliters and 500 milliliters together. So that's going to make 1,000 milliliters of solution, which would end up being 1 liter. So that ends up giving you a molarity of 0.025 molar. So that right here is what you're going to start with. Okay? Now the silver, that's not a common ion, so we're going to be starting with 0 there. Now, as equilibrium happens, as this stuff dissolves, this is going to go up by 2x. So at equilibrium, we're going to have 2x. This one is going to go up by x. So at equilibrium, we're going to have 0.025 plus x. Then we can use our KSP is equal to AG to the second power, because there's a 2 there, times CO3, oops, that's supposed to be a C, CO3 minus 2, this is supposed to be plus 1, to the first power. Okay, now they're giving us the KSP is 8.1, so we'll go 8.1 e to the negative 12 is equal to this 2x, because that's what it is at equilibrium, squared. And then that's going to be multiplied times 0.025 plus x. However, this x right here is going to be very, 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 very small. And to avoid using the quadratic equation, what we can do is we can just drop that x. You can drop it when it's very small. Okay? And so we'll just drop that. And then we'll work out the math here. And it ends up being that, let me go back to black here. It ends up being that x ends up equaling, if you do all the math, 9.0 e to the negative 6. Okay, that's what x is. But it wants to know what the concentration of silver is at equilibrium. So it's 2 times x. So we have to take 2 times 9.0 e to the minus 6 to get the concentration at equilibrium. And that equals 1.8 e to the negative 5 molar. That is the final answer. All right, so you should do this problem and check your work and see if you understand how to do it.